Okay, so what does this look like? Let's move you down there. I'll just keep you in reach. Um, that's not sine 2x, that's sine squared x up there. Or is it? So that's 4 sine squared x, take away 1 equals 0. So just need to remember that sine x being all squared. That's just the way they write it in the trig language. Right, new page. So put on the quadrant check here. But it looks like I need to get sine x on its own here. So technically I'm adding -1 to both sides, or some people think taking that -1 over the other side. Whatever you want to do, whatever satisfies your requirements, that's fine. Right, and I need to get rid of the 4 in front of the sine block part. So if it's multiplying, I say take over and divide. Okay, and get rid of the wee 2 now. That wee 2 is squaring up there, so I need to square root of the other side. Right, that looks fine. And if you'd been in a class, I would have interrogated you about what is the square root of a quarter, or what is the square root of 25. Then we'd have a little argument. But the thing is here, when we're not talking about distance, when we're talking about taking a square root, there's actually two solutions with real positive numbers. Two solutions. Positive square root of a quarter or negative square root of a quarter. Right, let's actually take the square root of a quarter. Your calculator would give you, well, square root of 1 at the top is 1, calculator answer. Square root of 4 on the bottom is 2. So that's positive or negative 1 over 2. Right, okay. Right, usually at this point, we would say, where is sign positive or negative? Okay, so that we might as well ask questions. So go for the upper one. Where is sign positive on one sign? Done. But the thing is, we need to ask the question where is sign negative. So that must mean the other two quadrants. So we've ticked all 4 quadrants. That's great. We can't make any mistakes now. So it looks like we're going to have 4 solutions here. And I'm sort of in the region 0 to 360, probably inclusive of 0. Right, but here, we can't solve directly for sine x. Regardless of whatever other people say, we can't solve directly for sine x. We need to solve for the calculator answer. So get rid of x. Okay, anyway, that was all the wee formulas there that you've memorised. Let's get rid of x. Bring in a. That's a trig stunt double. And we'll get rid of positive and negative. So officially, that's a hard positive there. Sine a equals a half. In your calculator, the a equals inverse sine of a half. Sometimes you call it sine with a b minus 1 of a half. It doesn't matter, as long as we know what we're both talking about. Put that in your calculator, press the button. What do you get? Yes, good. 30 degrees. It won't show the degree sign in your calculator. Right, let's go and take that answer and put it into all of our 4 quadrants. X equals a, x equals 30, 180 minus 30, 180 plus 30, 360 minus 30. Okay, that's what we're doing here. X equals a, 30, 180 minus a, 180 minus 30, is that 150? Yep, 180 plus a, 180 plus 30 is 210. And finally, 360 minus 30 is 330. Oh, bingo! That looks good. Okay, and if you're unsure, you can always take them and file them in. To your calculator, 3150, 210, 330. and your answers should be positive or negative half, and it just shows you they are there. So you should always do that at the end, just to confirm that what you've done is right. So that's what you should have on your bit of paper, because you don't have the magic board in front of you. Right, okay. I'm happy with that. Right, let's go for another one. 3 tan squared x take away 1 equals 0. And just go over the wording of that. 3 tan squared x take away 1 equals 0. So 3 times the tan of x, which is all squared, take away 1 equals 0. And I put in the values of x that I want to find my answers lying in, sometimes called domain. It looks like it includes 0 because I've got the less than or equal to x, and less than 360 goes up to 360, not quite includes it. Right, let's rearrange it. So let's get rid of the -1, add 1 to both sides, and I put in a wee coordinate check there, getting ahead of the game here, Tommy. Okay, get rid of that 3, let's divide both sides by 3. There you go. Get rid of the square, take the square out both sides, and remember, just like in the last example, it's going to be positive and negative. Okay, and we know we're going to be ticking all 4 quadrants here. Right, so where's tan? Both positive and negative. All sine, tan, cos. There you go. And there's your little formulas. They never change in this quadrant system here. But other techniques, you won't use this, but we are using it. So here we go. Let's bring A on board. So it would be tan A is the square root of 1 over 3. Just leave it like that there. So we're going to have the inverse tan of the square root of 1 over 3. That should give you a nice answer. 30 degrees. So let's fire it in to all our quadrants. 30, 150, 210, and 330. I am happy with that. So I think I'm going to leave that one there. Okay, no point in overcomplicating the matter. And as usual, you can rewind. So what we looked at there is these were really quadratic equations involving or trig equations which were quadratics in disguise, but we didn't have a b value. Um, so we could isolate sine, cos, or tan on its own. We took square roots, but we just had to remember when we're taking square roots, we were going to get a positive and a negative value, which that would yield up all 4 quadrants, well, provided it was 0 to 360-ish. Okay, so I'm going to let you go on that one. Okay, and we'll come back to something else. Bye for now.